Workbench, we'll go to Fluid Flow Fluent, add that, geometry, create new design model or geometry. With that open, we select the XY plane, hit the Z axis to align it. Then we go to sketching, rectangle, just create a rectangle, dimensions, general, H1, V2. H1 is 1 meter, V2 is 0.1, 0.01. Actually, yes, 0.1 meters. Here. Hit generate. And then we go to concept, surface from sketch, select this surface here, apply. Sorry. This sketch, apply. Then we hit generate. That creates us our surface. Then we go back to the workbench, mesh. Mesh open, we orient it. Then we begin creating a new mesh. To start this project in order to generate the mesh, we will first insert a face mesh here. In order to create the mesh, we will first insert a face mesh onto this surface. Then we will insert a sizing, edge sizing selected up here onto top and bottom. Type, number of divisions, again to these surfaces here. Type will be number of divisions. Capture curvature will be set to no. Behavior will be set to hard. Division number will be 100. And we will have no current bias. We will generate that. Then we will add another edge sizing to these two edges. It will also be number of divisions. Number of divisions will be 60. Capture curvature will be off. Behavior will be hard. Bias type will be the first selected bias. Bias factor will be 70. And we will generate that. Now this will cause this odd effect. And as such, we will add one more sizing to the final edge. Type will also be number of divisions. Again, 60. Capture curvature will be no. Behavior hard. Bias type. Bias type will also be this. Bias factor, again, 70. Reverse bias will be set to this. We will apply that. Then generate. And that will result in the mesh being nice and looking like this. Now that the mesh is complete, we're going to create the name selections by first selecting an edge, create name selection. This will be far field pressure. This one here will be plate. This one here will be inlet. This one here will be outlet. Now we're going to go to Workbench. Going to update Then we're going to go to Setup. In Setup, we're going to do this in double precision. Now that the setup is loaded, we will first change this type pressure. We will take this and make it a wall. Stationary, no slip. For the inlet, we will ensure that there is a velocity magnitude of 2 meters per second. For the outlet, we will ensure that reverse flow is prevented. Plate, stationary, no slip. And for far field pressure, what we are going to do is we are going to ensure that the type is set to symmetry. That way the software knows that that is basically the air, like as in outer boundary. Then now that we have all that set up, what we're going to do is go to reference values. Double check. That needs to be altered. 1.8 E negative 0.5. That is 1.2. Of course, we will compute this from the inlet. Then we will go to results, residuals, change that to 1 to the negative 6. Then for the viscous, set that to laminar. Fluid, once again, air with these properties. Reference values, again calculated from the inlet. And now that all of the battery conditions are met, what we will do is go to initialization, standard initialization from the inlet, x velocity 2, y velocity 0. We will initialize. What we will do, alright, going to run the calculations. We will set the number of iterations to 250. And we will double check. We will just calculate. Now that the calculations are complete, go to plots, XY plot. Pressure, we will go to wall fluxes. Then from here, we will go to skin friction coefficient from the plate. Now we would otherwise hit otherwise a file if you want to save to a file, but this is just for demonstration. Save and plot. That looks about right. And for the coefficient of drag, go to report definitions, new, force report, drag, plate, drag coefficient, and print to console. Compute. Okay, that looks good. Then we will go back here to video, save, solution, looks about good. Then we will go to the results. With the results loaded, we go here. We will create a contour, call it velocity profile, location, complete. Actually, we will do symmetry 1, variable, velocity u, number of contours, 110, and we will apply. Then we'll create another contour, call it pressure contour, location, symmetry 1, variable, pressure, global, contours, 110, apply. Now all we got to do is just deselect a few things, but first we're going to change legend view to horizontal, appearance from scientific to fixed, just to clean it up. Now from here we can toggle velocity profile, pressure contour. Okay, then we will go locations, line. So line, this will be our 35. This will be our 35. Look at location 1. This will be from 0.35 to 0.35, and this will be 0.1. Samples, we'll put 100 samples, apply. Okay, there. And we will insert new line, call it location 2. Let's be at 0.75. Let's be at 0.75. This will be 0.1, and again 100. Then we will create one more line, call it wall shear line, and this will be at 0.1524. Apply. So create a line. One. Apply. That will create a line going along the bottom that we can use for the wall shear. Now we go to chart view, create a chart, call it velocity profile chart. Title, again, velocity profile chart. Data series. First series will be 35 centimeters, located at location 1. We'll add another one, call it 75 centimeters at location 2. X-axis, the variable will be velocity u. Y-axis will be y. Apply. And it should look something like that. Now we will create one more, call it wall shear chart. Wall shear chart. Data series will be wall shear line, located at the wall shear line. The x-axis will be wall shear. Y-axis will, the y-axis will be wall shear, and x-axis will be x. Apply. go back to table viewer, sorry, 3D viewer, go to wall shear line, increase number of samples, apply samples 100, apply, and that should smooth it out until the project is complete. After that, you can export all of the necessary data to Excel and do all further calculations from there.